So what is Swift? As most people probably know already, new programming language by Apple, an alternative to Objective-C for mobile development. You can now write native iOS apps in a language other than Objective-C, which is a huge win for a lot of people. And of course, you can write Mac software using it as well. So Swift is object-oriented, static and strong-typed. It uses LLVM compilation, and it also uses the Objective-C runtime. And what that means is that you can combine Objective-C code and Swift code within your program, different files but within the same code base. So that's cool because it can make application migration much easier now that you can combine the two. So Swift got a lot of inspiration from a lot of the newer dynamic languages. So one of the direct results of that is it's terse. So I have an example here of initializing an array with elements in Objective-C and doing the same thing in Swift. So as you can see, it's not nearly as verbose as Objective-C. And it looks a lot like dynamic languages like JavaScript and Python and Ruby. Swift is also modern. The syntax is clean. It has closures. Functions are first-class types, generics, tuples, collection literals, and much more. And I'll be going over each of those things. All right, so the development environment, like Objective-C, and anyone who's done any mobile development for iOS devices, you have to use Xcode. For compilation, you need Xcode 6. Anything that's what Swift is provided with. Anything before that, and you won't be able to compile it. So one of the cool things about Xcode 6 is it provides a REPL, a read eval print loop capabilities for Swift that's similar to what's provided with dynamic languages like Python and Node or JavaScript with Node and Ruby. So that means you can run Swift code within the terminal. So I'll give a quick example of that. You just type in xc run Swift, and you have your REPL. So standard things, hello world, of course. And as a result of this, you can also run scripts on your computer. Instead of using Bash or Python or whatever you may be using, you can create a Swift file, enter in this line at the top, and you have a script that uses Swift. So that's pretty cool. I won't be using the terminal at all for this demo, but that's an option. And the third thing, the thing that I think is the coolest thing about the Swift environment are playgrounds. This is new in Xcode 6, and it's kind of like a REPL, but much more interactive and rich. It lets you see code as it's executed in real time. So that's what I'll be using for the entirety of this talk. I'm going to go to Xcode and create a new playground. So we go to new playground. I'll call it Surge Playground. All right, so here it is. As you can see, they have a line of code in here already. Hello Playground. You can see the output directly in the right. And you can add anything you want. And it should still show up. And you can also have console output, which you can see. Okay. So this middle column shows variable values, and the pane on the right shows kind of a visual, either a visual depiction of what the value is or a console output. So regarding the visual aspect of it, I can even have a loop. And we can see what's happening to the value as the loop runs. So let's see. Click the plus sign, and you can see how the value of A has been changing over time. So that's a pretty cool thing about playgrounds. Some other things you can do with this, which I won't show in the demo, but the options there, you can even build UI elements in here. You can show labels and what they'll look like. And this is great for just experimenting and learning Swift and just seeing what your code will look like instead of having to create a new project and building it and compiling it. So that's one really cool thing about Swift. And I'll be using this throughout the demo. So let's start writing code. So as you saw already, declaring variables is very similar to JavaScript and C#. Using the var keyword. So here I'm setting the name, and it's a string, so Swift is statically typed, which means you have to, if the type cannot be inferred, you have to specify it. So in this case, it'll return an error because there's no type. So in this case, you can run the type with a colon and then the type name. But of course, if we're initializing it, the type is not necessary because it will be inferred. So that's very similar to C# and JavaScript, other than the fact that JavaScript does not have types.
And Swift does have types, right?
Yes, it's strong and static. That's something to not forget. It looks very dynamic, but it's not. And you can use the let keyword for constants. So this will create an age variable, well, an age constant with a value of 27, and this can no longer be modified. This should return an error saying cannot assign let value age because age is a constant. Type inference I went over already, and another thing that Swift supports is optional types. This is very, very similar to nullable types in .NET. But basically, if a type is optional, it means the value could possibly be null, or as they call it in Swift and Objective-C, nil. So to make something an optional type, you have two options. You can either put a question mark, just like in C#. Okay, maybe not. Well, you can surround it with, oh, I know what I did, sorry.
You can't do a nullable constant, right? Is that your problem?
You can. Yeah. I put it around. You have to put it around the type. It's a nullable type or an optional type. So that's one way to do it. Well, all this means is that this value can be null. So you can actually set this to null, but then you'll never change it. So it's still a constant. It's just always going to be null. And the same thing you can do, just wrapping it around the text of the type with optional. And it's the same thing. And if you want to assign nils to these values, optional is required. So if these were not optionals, then it would return an error. Type int does not conform to protocol, nil literal convertible. And if you want to, so if the type is optional, let's say this one, and you want to get the value, you can unwrap the variable using exclamation mark. So that'll print the value of it. So the exclamation mark unwraps optional values. All right. So in addition to the standard primitive types of you have strings, ints, floats, all those doubles. One thing to note is that if you're coming from Objective-C, you no longer have to use the NS string and the NS int types. These new built-in types are native to Swift. So two other built-in collection types are arrays and dictionaries. So initializing an array is pretty straightforward. Similar to languages like Python. You just square brackets, and a comma separated list. And this will also do type inference. But if you want to specify the exact type, syntax will look like this. So the arrays have some operations you can iterate over them pretty cleanly. So using the for in construct. So and then you can, in this case, I'm going through each element and just printing double that element. So no iterating and keeping track of index values. You can also do that, but this is much cleaner if you're just going through everything one by one. You can also modify ranges in the array. So suppose I wanted to modify the second through the fourth element. I could do list So I specify the range that I want to access 3 through 5, index 3 through index 5, and I would like to replace it with 10, 11, 12. And now we can see that the array has been modified. 1, 2, 3, 10, 11, 12. And you can also replace it with less numbers than the range, and that'll just remove that last element. And you can do this even from within, in the middle of arrays too. So you can see that this replaced 4, 5, 6 with 10, 11, and 6 was removed from the list. And it also it has a standard array functions. You have appends, you can remove, and pretty much anything that comes with a standard library for this kind of thing. And the other collection type is dictionaries. And these are also similarly initialized very easily using this syntax. Where, in this case, 1 is the key and the string is the value. So now you have a dictionary. And of course, type is also inferred. If you would like to specify the actual type, you can do it with the following syntax: int : string. Or yeah. Now, just like in lists, you can iterate over dictionaries pretty easily. So you can iterate it in a way that assigns the keys and values to separate variables. So you could do so this will print key and value, and you can of course do every single element as well. And this shows in the console, it shows every single item as a key value pair. And of course, these dictionaries have the standard get and set operations that dictionaries and other modern languages have. So if you want to assign something to 4, you can just set 4 to map to turtle. So you can see. So those are arrays and dictionaries. Much easier to work with them in Swift than it was in Objective-C. Control flow, for, if, while, and do while, these are all pretty standard. Second, I lost my. Okay. So you saw how to use the for loop while iterating over collections. You can also do the standard iterating over a range of numbers. So if you would like the value of I to iterate over 0 through 10, inclusive, this will include 10. You would just type in 0 dot 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 10. Get rid of this. And if you don't want to include 10, suppose you're iterating over an array and you need to keep track of the index. You could just do dot dot and then less than sign, and it will go from 0 through 9. So this will come in handy when iterating over lists. And notice that they do require curly brackets for the body, but they do not require parentheses. So it's similar to the C-style languages in that regard, with where you require curly braces, but you do not need parentheses. Same with if, while, and do. The actual conditions themselves do not require parentheses, but the body requires curly braces. And I won't bore you with the while and do while. They work exactly the same way. So functions, for the most part, function declaration is pretty straightforward in Swift. Every single programming language has their own little way of doing it, but in Swift, you do it with the func keyword, and then the name. We'll create a function called add numbers. And then parameters, we'll say A is the first parameter. We'll call it first, and we're going to declare it as an int. And then second, we're going to declare that also as an int. And if this was a function with no return value, we wouldn't need to do anything else, and we just work on the body from here. But of course, we want this to return another int. So we're going to do an arrow and then int. And here we will just add first plus second. And this will, calling the function is just like any other programming language. Now, one thing we can do is you can create internal parameter names. So suppose we want the person using the function to only see first and second as the parameter names, but internally inside the body of the function, we want to use something else. Suppose we want to call it A. Suppose we want to call it B. This allows us to use A and B in the actual body. And in this case, you also have to name whoever's calling the function also has to give the names of the parameters. So this would be useful if you're trying to create self-documenting libraries with perhaps long parameter names, but you don't want to be reusing that throughout your code. You can also have multiple parameters. So suppose we want to be able to add as many numbers as we want. We can do the same thing. But then after the first parameter, we'll add a dot, dot, dot. And what that does is it turns the nums into an array of ints. So let's see. So we're going to loop through the array. And we'll add it to the result. And we'll return it. And now we can see so this will accept any number of parameters or any number of arguments. We can also add 4 of them and to give us a different value. And another thing about functions in Swift is their first class types. That means you can assign functions to variables. You can pass them as arguments to other functions. You can return a function from a function. So which is pretty cool. So we'll assign function to be the add numbers function. And then we can just call function this way. It works exactly the same way. And you can also return, I'm going to copy some code from a previous playground so I don't have to go through all of it again. But you can also return functions as results of other functions. So here we have the add numbers function, returns a double. We have the multiply numbers function, and it returns a double. And then we're going to create the get function, which is going to return a function in which follows the signature of accepting doubles and returning doubles. And in this case, we can see that if you put in a plus sign, it'll return the add function. Oops, that should be a string. By the way, there's no good reason to create a function like this. I'm just showing capabilities of the first class functions in Swift. And then same thing. It's just returning a different function depending on the parameter. So most of the other languages we use at Surge can have these capabilities, but it's pretty new for Swift. All right, closures. I'm guessing most people here are familiar with them. Most of us here are JavaScript developers, and most dynamic languages these days support closures. So we can use these with array. For example, we can use these with array functions like map and filter and sort. I'll show some examples with it. So I have a list, the same list that we were using earlier, numbers from 1 through 9, and I would like to double every single element in this list and create a new list out of it. So we're going to map it. We're going to use the map function for this. So in here we would put in a function that should be called for every single element. So closures, to declare them, you put them inside curly braces. So we're going to put curly braces here. And now the rest of it is similar to our function declaration from before. So we'll have a parameter called item, which is an int. And this will have a return type of an int. And when you want to type the body in, you have to use the in keyword. And here, this is where you type the body and what you want the return value to be. Okay. So just mapped every single item to a value twice that item. So now we have a new list with 2, 4, 6, 8, 10. Now, since it's closure, it's also able to access variables from outside the scope of the function. So let's create a multiplier, call it 3, and we can still access it from within the closure. So now we have a new list where everything in the original list is multiplied by 3. And you can use the same kind of thing with filter and sort and all the other functional methods that you can use with arrays and any other data type, really. Now this is kind of verbose for closures, so Swift allows you to clean up the syntax a little bit. So in closures, by default, the return value will be the last statement, in the function body. So I'm going to get rid of return. And you can see that it's still resulting in the same maps list. Now, it will also do type inference. So you don't need the type. So I can get rid of int in the parameter list. So we have everything working as expected. Since it's type inference, we can also get rid of the return type. And now, one more thing that you can do to make things cleaner is, you can use named arguments. So by default, since there's one argument, you can use a $ and the number, the index of that argument. So in this case, item is the 0th argument, so we would just do $0. And there you go. And now this is the exact same function, but in much shorter syntax. And you can put it all on one line. Okay, so classes, like I said, Swift is object-oriented, so we have classes. Classes are declared in a pretty standard way. With the word class, name, curly brackets. And this is enough to create a class. To initialize it, you could just do the name of the class and then 2 parentheses. And now you have a person object. So Swift classes support properties. These are very similar to C# properties, even in syntax. So suppose I want to give the person a name property. We'll call it name. And since this is not initialized, we need to create a constructor method, which you can do by creating a method called init. And we'll take in the name argument. And you use self to get a reference of the class that you're working in. So self.name equals name. So now we have a person. Oops. And okay, so methods that are inside of functions require parameters to be named. So in this case, we have to provide the name of the parameter. And now we can access this pretty easily with just using the dot operator. Now you can also your properties can also have getters and setters, just like in C#. So we'll create an age. That's an int. And we'll give it a getter. And a setter. Actually, I'm going to do something else. I'm going to create a read-only property called age and dog years, and I'll give them another property called age. And I'll make this initializable. And this is going to be read-only, so I'm going to give it only a getter. So I don't know what the formula is for age and dog years. I'm going to assume it's age times 2. So we'll just have it return age times 2. So now we have person's age, person's name, and we can also get a computed property of the age and dog years, which in this case is 60. Now, you can also give classes methods using the standard function, syntax. So we'll just create a function called print name. This will be a no return type, so I don't need to put anything. And we'll have this print self.name. Now, if you call person.printName, you can see in the console output that it's printing out name :John. And another thing you can do is you can give it subscript capabilities. So subscripts are the values between the square brackets that you use to access arrays. You can give that capability to any of your custom types as well. And you can do this using subscript keyword. And you can specify the input type, and the return type. Actually, I'm going to have it return a string. Now I'm going to have the subscript return the name with the string appended to it. So now we can print. Can you guys hear me still? I heard something cut out.
Yeah, we can hear you.
Okay, sorry.
Yep.
Okay, so now that we gave it the subscript function, we can just access that value by doing person bracket and then the value in it, and then it will return name and then the number. Now I don't have slides prepared for this, but classes can also implement protocols, which are just like interfaces. A protocol pretty much specifies what methods or properties a class needs to implement. I don't have the syntax down for it, so I'm not gonna show you guys that right now. But instead of interfaces, they're called protocols, and they work pretty much the same way. Now, one other thing you can do, which will look familiar to extension methods in C# and categories in Objective-C, is extensions in Swift. So with extensions, you can add properties, methods, and subscripts to existing types. So what I'm going to do is I'm going to assume that the person type doesn't have these three functions that I added. I'm going to get rid of the property, the function, and the subscript from the person type. Then I'll show how to add it using extensions. The syntax for this is pretty simple. It's just you type an extension, then the type name, which in this case is person, and then curly braces, and then so in the case where you want a property, you would just like you would create a property in a class, you would define it using the var keyword and the type. So I'm going to add the age and dog years property as an extension to the person class. So now you can see that it's not a part of the original person class, but I've added it as an extension, and we can still access it in the person class, and it will still print out the same value. You can do the same thing with methods. I'll create a function called print name with no return type, and we'll just have it do the same thing as before. And you can access anything that's in the class using the self. Oops. And now I added the print name function as an extension to person so I can access it. Just like before. And you can see it in the console output in the top right. And the same thing for subscripts. You can add these as extension methods. So I'll add a subscript that accepts an int and returns a string. And we'll have it return the name plus. We'll just append the number to it for now. It's easy. Now we'll print. And you can access the subscript just like before. So that shows you how you can add functionality to existing types pretty easily. So there's a lot more that I didn't get to cover. There's different enumeration types and structure types that I didn't get to go over. But these are some of the cool things that I thought were worth presenting.